Hey, in the previous video, I explained how to calculate the variance. I defined the variance as the mean of squared deviations. And I told you that there are two different formulas to calculate the variance. But remember, so far we assumed that the original data are given in this format. And in calculating the mean or calculating the median in the previous chapter, I divided the cases into two cases. One is when you have the raw data, and the other is when you have a probability distribution table. So what I just showed you, the formula I derived applies only to the raw data, only when you have the raw data. So when you have these like raw data like this, even if you have more than 4, does not matter. So calculate the mean, subtract the mean from all the observations to obtain the deviation, and then square the deviations, and then calculate the mean. But when you calculate the mean, you may choose which formula you are using. And the sample variance is a more commonly used formula. So to summarize, this is how you calculate the variance when you have raw data. So calculate the mean, subtract the mean, square the deviations, and sum the square deviations, and then divide the sum by either n or n minus 1. So that's how you calculate the variance. So as an exercise, I want you to try this. Now, so far we calculated Honolulu's variance, and now I'll have you calculate the sample variance for Phoenix, Arizona. So suppose that you have 4 observations, simply 4 observations, and I kindly calculated the mean, uh, which is 75. So the first step is done. So uh, you use paper, or you may use Excel, whatever. It may take a little more time than calculating the mean, but I want you to do this. And also, remember, we would like to use the sample variance formula. So I specified that it is the sample variance. So use n minus 1 in the last step, right, in the denominator. So do it to calculate, and when you finish calculating the variance, then we will move to the next page, right? Do it, pause the video. Okay, I'll turn the page, I'll turn the slide. So the mean is 75, and if you like, you may want to make a row, additional 2 rows. First, subtract the mean temperature. So -2. In spring, the spring is 2 degrees below the mean, and summer is 20 degrees hotter than the mean, and fall is 2 degrees above, winter is 20 degrees colder than the mean. And then -2 plus 20 plus 2 minus 20 are squared. So 400, 400. They are square deviations, which is a kind of distance. It's a kind of distance. And then the variance is the mean of the squared deviation. So you sum these 4 numbers, but because we are using the sample variance, you need to divide the sum by 3, not 4. This is the confusing part, but it's not that difficult if you just apply the formula. It's nothing special. So the answer is 269. Compared to the Honolulu's sample variance, so Honolulu's, of course, because it was the sample variance, you have to compare this with the sample variance, not the population variance. So Honolulu sample variance was only 13. So if you compare these two measures, it clearly captures the large variability in Arizona, right? So this is how you calculate the variance from the raw data. That's what we do. Next topic, as you may expect, is about how to calculate the variance when you have a probability distribution table, right? So it's we are following the same structure for the third time. So you must be you must be comfortable with that. So now let's think about another example. Now I'm going to consider a different example. Here we have a financial asset. Financial asset has this probability distribution. So you invested, like say you you invested in stock, like say Tesla, and then you expect 40% it returns $20, or 20% increases 20%, and another 40% zero. Nothing happens, does not change, but minus 20 but at the remaining 20% your investment loses $10 or 10%, whatever you think. I will call this $10, $20. And in this investment, the variance will capture the risk, right? So the risk of the investment can be measured by the variance. And then remember, the variance is the mean of squared deviations. That was the definition. So our plan is we are going to calculate the squared deviations first, and then we will calculate its mean. And let's start. The first step you have to do is to calculate the mean, because you have to calculate the deviations. To do that, you need to have the mean first. So mean is the very first, the very first step to calculate the variance any time and in any case. So you know how to calculate the mean. So multiply the outcome to its probability to obtain probability weighted outcome. Probability weighted outcome minus 208, and their sum is the mean. So the mean is 6. So on average, you can make $6 profit, from the investment, right? The mean, but it's not important. The mean is just a mean. And we are going to calculate the deviations by subtracting the mean. But you are subtracting the mean from the outcome, right? So when you if you lose $10, that means this is $16 below your expectation. And if you there is no gain, no loss, zero means it's below $6 below your expectation. If you make $20, then it exceeds your expectation by $14. So in that way, the deviation captures the difference between the realized gain or loss from the expected gain, which is $6. And another thing you need to notice here is that I'm not using the probability. So probability does not is not needed to calculate the deviation. So once you obtain the mean, you don't need to look at the probability. The probability will be used later. So deviation is still the simply subtraction between the outcome and the mean. So that's that. And then the next step is calculating the squares. Square the deviations. That's also simple. You obtain the deviations, simply square them, right? Square them. Again, I did not use the probability here. It's just defining transformation of the outcome, right? transformation of the random variable. So probability does not change, but only the outcome uh, changes to another scale, another unit. So you obtained square deviations, right? And then the last step is now you get a new probability distribution table for square deviations. Remember, it was a kind of transformation. You transformed the gain and loss dollars into squared deviations. And now you are calculating the new random variables mean, which would be which will be the variance. So this is what you need. After transformation, you get these numbers and the probabilities do not change, right? So calculate the mean. There is no you repeat the same thing you did at the first step. So outcome times its probability, and you get probability weighted outcome. Say do the same thing line by line, and then sum the probability weighted outcomes. Sum sum all these three numbers, then you get 144 as the final outcome. So the variance of this investment is 144. That's the risk in terms of the variance, right? So it's more complicated. Maybe the most complicated algebra you will see in this course, maybe. So actually there are more, but anyhow, it's one of the most difficult algebra uh, in this course. And let's review. First, calculate the mean and remember how you calculate the mean, and then calculate the deviation, and then calculate the square deviations, and then calculate the mean of the square deviations. That's the same steps as before, but you have to adjust the probability. You have to adjust the technique to use the probability weights, right? So here is a simple summation of a summary of the steps. Calculate the mean, subtract the mean from each observations, square the deviations, multiply probability, and sum the probability weighted squared deviations, right? And another note here is when you use probability distribution table, there is no differences between population or sample formulas because the probabilities are given. There is no room for n or n minus 1. So in this case, there is no different formulas. It just depends on whether the probability is population probability or the sample probability. So in this case, it's in that sense it's easier. Okay, I think it's a good place to stop, and I'm going to call it a lecture. And in the next lecture, I'm going to extend this example to more complicated cases to understand to derive some properties of the variance. So it's a little bit shorter than usual, but I think it's difficult enough. And I want you to rewatch if you are not comfortable with the variance. Okay, see you later. Have a nice weekend, and see you later. Bye bye.